Hello and good afternoon, everybody. I welcome all the participants and we are very glad to have you here today for this session. We are using GoToWebinar interface for conducting this webinar. We would like to inform you that this webinar will be recorded and the recording will be made available to everyone. We will keep your microphones and webcams on mute for the entire duration of the webinar to avoid any accidental background disturbance. During the webinar, if you have any questions or comments, please share the same using the question or chat options available in the panel at the right side of your screen. We will take the questions at the end of the webinar during the question and answer session. So with this bit of housekeeping announcement, I would like to invite Mr. Sanjay Dubey, President and CEO, International Institute for Energy Conservation, to deliver the welcome address. Over to you, sir.
Thank you, Sonia. I really welcome all of you who basically belongs to the esteemed organization where you are sharing the details of these technologies, and on SDC officials, our partners, EDS, BASE, Megraj, and all others who are attending this webinar today. And this is a very key platform where actually we really want to share the direction that the project is taking, and a deep dive details about the technologies that the project is going to deploy in the market. Very briefly in the beginning, and also before that, I also welcome Mr. Jonathan, who has recently came to India to head SDC, and he is looking after this program as well, and Mr. Anand Shukla along with him, who is the program manager for this program. Jonathan has some history working in India, which Sonia, when invite him, will present about his bio. But it'll be interesting for us and him to, listen to all the esteemed speakers on this webinar. We initiated this project last year with an objective to come up with a list of selected renewable energy technologies which could be useful for buildings in India, and not only at the very design stage when you decide about the technology, but also the buildings who are upcoming and commissioning. And this is how the technologies can basically integrate very well with the buildings. Our partners EDS have developed a very useful tool, and that tool really help us in finalizing these technologies. And the entire journey does not stop here. We're going further with some of the pilots that we are selecting at this moment. We're very close to signing some memorandum of understanding with some pilots whom we'll be trying these technologies as a demonstration in India. And one of our key partner, Swiss partner, based in Switzerland, they are going to help us in working out a couple of useful business models to take these technologies further and see how the buildings basically require some kind of a gap or other kind of a funding or existing use of existing mechanisms in India to integrate these technologies in the buildings. So overall, this is a very important project, and very high expectations in the market at the right time, where we really need a lot of working on renewable energy technologies, So with this, I basically hand it over back to Sonia, and welcome again. And we look forward to hear from all of you, and then some question and answer at the end, as Sonia mentioned. Thank you. Over to you.
Thank you, Sanjay sir. Now I invite Dr. Jonathan Dimensch to deliver his address. Dr. Jonathan is the head of cooperation for the Swiss Agency for Development and Cooperation in India. He has arrived in India just recently in the beginning of October. Previously, he was the country director of the international NGO JERIS in Tajikistan, working on energy efficiency in housing and agriculture. Trained as an anthropologist, he holds a PhD from Institute of Development Studies in Political Ecology on road construction in Ladakh. His thesis was on road construction in Ladakh, and he has also calculated the first ecological footprint of the subsistence farmers in Ladakh. Earlier, he has worked for the Netherlands Development Organization, the Overseas Development Institute, various NGOs, and as a researcher in Nepal, India, Tajikistan, Ethiopia, and West Africa. Dr. Jonathan, we welcome you for this session. Over to you.
Thank you very much, dear Sonia. Thank you also very much, Mr. Dubé, for your kind words. And first of all, I would like to wish you all a warm welcome. So warm welcome to all participants and panelists. I think for the bio it's done, but thank you very much for this. Yes, as true as I've worked in India before. Somebody was trying to convince me yesterday that probably I've worked in India in my past life as well. That I'm not so sure. Um, but I think what we are undertaking now is such a pioneering and ambitious project that I have the feeling that everything I've done before doesn't really matter, because we are really starting something fresh, starting something that has the potential to be a game changer, not only for India but much beyond. So let me focus on this. Countries and global organizations are increasingly committing to move towards the net zero carbon buildings, and therefore aligning towards the 1.5 degrees ambition of the Paris Agreement. We all know that the task is immense, and we still have many rivers to cross and many roads to walk for a civilization like ours, so dependent on widely available, relatively cheap, and always dirty fossil fuels, that we got so used to wasting them. And such transformation will not happen overnight. But increasingly, countries, states, cities, and citizens are taking stronger commitments, and short-term, medium-term, and long-term commitments are starting to get aligned. Yes, our house is on fire, as it was quite, reminded us not long ago. But increasingly, we are not anymore looking elsewhere. And increasingly, generalized net zero carbon buildings are not anymore a distant dream. This commitment is unique in positioning energy efficiency and renewable energy as a central component to achieving decarbonization in the building sector. So we know that buildings are responsible for about 40% of carbon emissions globally and consume more than 30% of the electricity. This is also roughly the case in India. And as people become more affluent and temperatures increase due to global warming, so will the energy and carbon footprints of our buildings in the future, locking us into high energy consumption and CO2 emissions for decades to come if nothing is done. So let me give you a glimpse of what the Swiss Agency for Development and Cooperation does in India. About its focus on climate change and what Switzerland has to offer in Switzerland and abroad. And to start with Switzerland. Switzerland has been quite innovative, has been #1 in the Global Innovation Index ranking for a number of years. It's among also the first few countries that displayed high performance on Environmental Performance Index. And it's also a country which considers climate-related issues seriously. At home, Switzerland is working on its new CO2 law, which heavily taxes the use of fossil energies and reinvests the income of it into energy efficiency and renewable energy measures. And over the last decades, the norms of energy efficiency of old and new buildings have been improved. Energy renovation programs have been conducted on a really massive scale. And the immense majority of new houses and renovated houses include some renewable energies today, whether it's photovoltaic, solar thermal, biomass, and heat pumps. Heat pumps are a big hit in Switzerland. And already in 2005, 50% of new houses included heat pumps, enabling dwellers to heat and cool buildings at a minimal cost. The other success story is that of the Minergie label. It's been quite a success, and 50,000 buildings have been certified over the last 20 years. That's about 10 to 25% of new constructions. So yes, Switzerland is innovating. And abroad, climate change is also one of the 4 main themes of its foreign development policy, and probably the most important one, which is why SDC is very active in India, but also in China and Latin America. So Switzerland has been cooperating with India with significant results, both in climate change mitigation and adaptation. And one example, for instance, is the Ekoniwa Samhita, the Energy Efficiency Building Code, which was developed jointly with the Bureau of Energy Efficiency. Also, GLOF guidelines, which were recently released by the National Disaster Management Authority. So India is a global player. It's a global influence. And it is showing the way in the development of solar energy, for instance. And we also do expect India to play a major role in climate negotiations. And to give you a few glimpses about our past experience of working in India, I'll cite one program, which is relevant today. So for the last 10 years, SDC has been supporting a project named Indo-Swiss Building Energy Efficiency Project, BIP, which has shown that 30 to 45% of energy savings are possible by adopting various energy efficiency measures in buildings. And our experience indicates that renewable energy technologies also have an equally important role to play. India has made rapid strides on the implementation of renewable energy technologies. The country is at the forefront and is currently ranked number 5 on wind and solar energy installation development. However, the challenge now is to make buildings shift from energy consumers to that of energy generators. And in order to support this project, SDC is adding to its work on energy efficiency another component, which is the integration of renewable energy in buildings in India. Together, the project aims to make building prosumers and not consumers by integrating different renewable energy technologies into buildings, not only solar, but all renewable energies that are relevant for India. Just to remind the objective, the specific objectives are first, to demonstrate 2 to 3 commercially viable renewable energy technologies for building applications. Second, to develop appropriate and viable business models for wide-scale dissemination through policy interventions. And third, to bring training and capacity building support in order to disseminate knowledge. And while doing this, it's fundamental that we engage with the private and public sectors while developing realistic deployment strategies. So today's webinar engages with technology providers to seek answers to some key questions. First, what kind of technological interventions are available for buildings and at what cost? And second, which models should the project support for de-risking investments and promoting the increased use of renewable energy in buildings? Another fundamental question. So I'm very glad to see the esteemed speakers in the panel, and I look forward to listen to all of them with great interest. But before I hand the floor, I just want to think with you of how significant working on homes is. Working on homes is doubly symbolic. First, because working on homes gives all of us the means to act locally at our scale, immediately on issues we often think powerless about. And it gives us the opportunity to each individual, each family, to act on his or her energy consumption and carbon footprint, and therefore to give the legitimacy to ask others to do the same. And second, and maybe even more importantly, this home that we are talking about is representative of a bigger one, our planet. The only one that we have and the only one that we share. And if we humans learn to live within the limits of our home, then it gives the hope that humanity can live and share the resources of our own planet, of our one planet. Thank you very much for your attention.
Thank you, Dr. Jonathan, for those encouraging words. With this, I would like to start our technical session. I have an excellent cohort of speakers today, but due to paucity of time, I would request all our presenters to limit the presentation to 6 to 7 minutes. We will take all the questions at the end of this session, and therefore I request all the speakers and participants to stay with us till the session ends. First, I would like to invite Mr. K.R. Hari Narayan. Mr. Hari Narayan is the founder and CEO of U Solar Clean Energy Solutions. USolar provides end-to-end solutions from designing, engineering, project management, as well as post-sale services for solar projects. And USolar is proud of commissioning one of the largest BIPV projects in India. Mr. Harinarayan believes that renewable energy, with its advantages in distributed generation, short turnaround times, clean origins, is the answer to a multitude of problems ailing the power sector in India. He shall be specifically speaking on BIPV and solar solutions today. With this, I invite Mr. Harinarayan. Over to you, sir.
Thank you, Sonia, for the kind introduction. And good evening, good afternoon, everybody. I run a company called USolar, and we do a lot of rooftop installations. And in 2019, we were very fortunate to be able to work on a very large BIPV installation. What exactly is BIPV? BIPV is, of course, stands for Building Integrated Photovoltaic, but essentially here it talks about architectural elements that go into the building and are visible. So just putting some solar panels on your roof, that really is not BIPV in the classical context, but it is more an architectural element such as a shading or a curtain wall or a skylight that actually generates electricity. And because the traditional rooftop solar panels, that is a very done and dusted activity today. It is commercially viable and easy to do. But doing BIPV, where you integrate architectural elements, is a lot harder. And essentially, in case of BIPV, if you think about it, there are about 3-4 different types. The first is the skylight kind of thing, which goes on the roof or probably on a parking lot, where it is sort of at an angle on the roof or on your parking lot. The second is what we call a sunshade type along the elements of the building. The third is what we call the facade itself. And so in that, I'd just like to introduce, two kinds. The spandrel glass is actually interesting because what happens here is these are glass elements on the building which actually don't have any anything behind them. Essentially there's cement or some other thing. So essentially what you can do here is use that to, it is quite inexpensive to generate electricity on spandrel glass. Doing it on glass wall, which lets in light as well as has certain effects on people inside, is a little bit more tricky and a bit more expensive. But spandrel glass actually is economically viable, as we have shown in our installation. So this is, so just want to talk about our case study. This is actually one of the largest installations of BIPV in India. It's almost about 863 kilowatt, where all sides of the building we put solar panels. This is about 5,000 square meters in size. The north facade had about 550 kilowatt, and the south facades, southeast and southwest, northeast and northwest facades, about 312 kilowatts. So what we did here was essentially the builder was going to put regular glass, and in this case what we have done is substituted the regular glass with solar glass. So the real cost, the like-for-like comparison is replacing regular glass with solar glass, which makes it more economically attractive in the sense that you're anyway going to put glass, and here you've put solar glass. So the installation costs are the same, and essentially you have a generating facility that is generating solar. And in this case, we used module level monitoring, so that the entire building is mapped, and if any specific module is malfunctioning, that comes up at the online integration. And also for fire protection, this is very useful. And so we are kind of extremely happy. This actually works out economically. We've shown that you get about a 5 to 6 year payback, especially when your cost of electricity is significantly high. For instance, in Mumbai, it's upwards of 9 rupees. So in commercial buildings, on certain facades, these kind of installations actually economically viable. Oops, let me just skip back. Yeah. So essentially, what was the final result was the 20% increase in investment for the solar integration, and this particular facility is generating about 50,000 units, 50,000 units average monthly. And if you did a payback analysis of this incremental investment versus the generation, the customer found it was about 4 to 5 year payback. In terms of generation, obviously the south side, this is actually live data which we tracked for a year. The south and southeast and the southwest facades were much better than the northeast and northwest facade, and this is not surprising given that we're in the northern hemisphere. And so it makes sense to put solar on your south facing facades. Again, obviously the generation is not as good as it would be if you just did it on your roof, simply because this is a vertical facade. So the generation is about at 50% of what you would get on your roof. But nevertheless, if you're planning to do put glass, then you might as well put solar glass, and that is really what the data is showing us. So I think, yeah, with this, I'd just like to conclude. Solar, BIPV is economically viable in certain cases, not everywhere, and especially with the cost of electricity is high. And I think for a net zero kind of situation, this is absolute. I mean, if you're looking for net zero building, putting solar panels on certain facades is part of that journey. Yeah, thank you all.
Thank you, sir. Thank you so much. This is very interesting, and I hope our audience will take a lot of information from this, and they will definitely have a lot of questions on this. We will get back to them later. Next, I would like to invite Mr. Rajesh. Mr. Rajesh heads the business development and partnerships for GPS Renewables. GPS Renewables is a Bangalore-based clean tech firm founded in 2012. Its core products are the BioUrja, a state-of-art modular biogas plant, and the Biogas Bot, a proprietary AI solution for remote predictive bioprocess management. The company has close to 100 BioUrja installations across India, Bangladesh, and Sri Lanka. And these installations are with Fortune 500 companies such as Microsoft, Intel, Bosch, Cummins, Saint-Gobain, Reliance, JW Marriott Group, and the Tatas. Mr. Rajesh relishes the opportunity to focus on solid waste management through BioUrja, the class-leading product in biomethanation. Mr. Rajesh, over to you.
Thank you, Sonia, and thanks the organizers for giving us the opportunity to present this solution to the really august audience. I think a few slides have been taken over already by Sonia, so I can just go ahead and continue. The control is not with me. Yeah, right. So just on that, we are basically a waste management technology company. Compared to pure play power kind of situation, we are into waste management primarily, and the product itself was chosen by people the founders who had both engineering and management expertise, who wanted to do something on the business on the social impact side, decided on waste management and chose biogas primarily because of the output, which is renewable energy. Now, considering that what comes out, which is relevant to this particular talk, is a replacement of fossil fuel. The flexibility is what of output is one of the key areas here that I'd like to talk about, because we can replace not power is not the only output that we can generate. Anything which is presently using fossil fuel, which is LPG or CNG, PNG, can be replaced by use of biogas. There is a bit of lag. So we have just another few seconds on the awards that we have won. Right from the year that the company was started, we have won awards internationally as well as in India. The last one, which was actually earlier this month itself, was from the World Biogas Association and AD by UK for being one of the best biogas plants available across the world. So the solution snapshot looks like this. We have waste management as a major area and also renewable energy. So we have a combination of both. Certain sectors are primarily looking at the waste processing solution, which is a regulated requirement in India. And there are classes which require both processing as well as usage of renewable energy in whichever form. And you have a class of consumers who have a huge requirement for use of renewable energy, primarily because of the targets to be carbon neutral, net zero by 2030, 2035. So we address this entire market. But in this specific case, we talk about two different solutions that we have. One is called the Bio-Urja, which just now Sonia talked about. And the second one is called the Disparate, which is a separate solution altogether. So Bio-Urja can be seen as an energy supplement, while the Disparate can be seen as an energy replacement. This purely shows the scale of the solution. So most of people who have thought about, or interacted with biogas as a technology would probably have in their mind something which is shown as the left bottom extreme. This is the conventional legacy biogas plant, and this has over decades improved in terms of aesthetics, in terms of material of construction, a lot of things. But what hasn't changed are a couple of things which related to the reliability, the productivity, the usage of biogas in the urban sphere, which is what Bio-Urja has done through its prefabricated, online monitored device, which we call Generation 4. So there are a few key queries that come up when we talk about biogas plants. I've just touched upon these in terms of smell, reliability, gas storage. I only want to say that each of these components has been resolved in totality with the technology that we have developed. The rest of it, if there are questions on this, we can have it. So this is what our product looks like. This is at an establishment which is one of the largest semiconductor companies in the world. Replaced a unit which was using legacy systems. A few numbers that I talk about here is that if you have 1,000 kilos of waste that is processed, which is a regulated requirement, from the Bio-Urja, what you get out is an equivalent biogas quantum which can replace 70 kilos of LPG, which is 5 domestic cylinders. That is on the fuel replacement side. If the same volume has to generate power through usage of a biogas genset, what we generate is 200 units of power daily. For generating this quantum, the space requirement is what is most interesting. That this 1 ton generating either 70 kilos of LPG replacement or 200 units of power requires 500 square feet of space, maybe 600. But that is a typical number that you can keep in mind. There are other things like customization. We can put the biogas in the smallest possible place. Nobody else can. These are all additional factors to it. But this is in essence the numbers that we're looking at. So
sorry to interrupt, Mr. Rajesh. You just have 1 more minute to wrap it up. I'm so sorry.
So fair enough. So these 2 slides I'll cut across. These are things that you can discuss in detail. The second solution that we provide can you see this change? Next one. So this is what we call for the energy replacement side, where the consumer that requires a lot of energy replacement in terms of green fuel can have that. And with our system where we can separate out the waste processing side, people who want only the waste processing can have that separately at a very small space, very small investment. While on the other side, at a very competitive price, the large consumers can have pure gas generation at site without waste entering the space and use it either for process heating or for process power. So this indeed, these are, in terms of the graph shows the kind of space requirement here for generating 5,000 units of power a day. This requires at the energy consumer side around 600 meters of space, 600 square meters of space. I think, yeah, I'm almost run out of time, but these two advantages, multiple things that I can look at in terms of regulation side and the waste processing side separate. Only, yes. So what this essentially does is that it does a lot of things in terms of decentralization, local processing, local power. This makes it affordable, and you have a significant impact on usage of renewable energy where required, and it solves basically three specific issues in terms of affordability, in terms of decentralization, and in terms of renewable energy. These are some of the names that have been with us for some time. Most of them have repeat projects across their properties. Thank you so much for the team who have helped us talk to this gathering. Thank you so much, Sonia.
Thank you, Mr. Rajesh. Indeed, this is a very interesting technology, and I'm very sure that a lot of participants would be interested in getting the details of it. We will take the questions, and we will also put you in touch with the people who are interested to talk or understand more on this. Sure. Next, I would like to invite Mr. Praneeth. Praneeth is founder and technical lead of Bird's Eye Energy. Bird's Eye Energy is a green energy company that develops, manufactures, installs, and provides maintenance services for innovative green energy technologies. Bird's Eye Energy is currently focused on solar technology, particularly innovative, first of its kind in India, the duplex solar panel that can provide 330 watt of electricity and 75 liters of hot water per hour of a single panel simultaneously. Mr. Praneeth is a graduate of batch of 2007 with a BTech in Aerospace Engineering from IIT Madras and MS graduate in Renewable Energy from the University of Florida. He aspires to build Bird's Eye Energy into an innovation leader in the energy segment in India. Mr. Praneeth.
Hi guys. Thank you, Sonia, for the great introduction, and thank you for IIEC and the organizers for making this event happen. So again, welcome to all the audience. We're great to share. It's great to share our passion about green energy technologies with all of you. So we are Bird's Eye Energy. We are an R&D based energy company started from IIT Madras. And what differentiates us from a lot of the other solar product companies is that we develop unique and patented technologies which are first of its kind in India. And these technologies are not one size fits all. These are technologies that are developed specifically for a market segment. And that is how we are able to make sure that we deliver the best value, not just compared to other green energy, but compared to any other energy technologies. We are able to deliver the best value for that particular target segment. So we've, as Sonia said, we've developed India's first 2-in-1 solar panels, which are also the most efficient solar panels in India. So let me walk you through our technology. So there are two types of solar technologies in India right now. So one is solar PV. The other is solar hot water systems. Solar PV, like generates electricity. Solar hot waters generate hot water systems, and these are completely independent of each other. And each of these technologies have their own pain points when it comes to customer acceptance. So the PV systems usually take up a lot of rooftop space. The energy output is too low, and the payback period is too long. And the hot water systems usually have a short life, so just about 7 to 10 years, and they have a lot of scaling and maintenance issues, especially if the water quality is bad. So this is why, although the open source solar has been really booming in India, the rooftop solar growth has actually been stagnant or has been slowing down for the past few years. So, and in India, geographically, we are blessed with a lot of solar resource. So it really makes sense that we should try to utilize more and more of that resource. So that is how we developed India's first two-in-one solar panels. So two-in-one is more like a marketing name. The more technical name is PVT. So PV stands for photovoltaic and T for thermal. So our panel is actually made out of 2 layers. So the top layer, as you can see here, is similar to a PV layer that absorbs sun's energy and it generates electricity. And in our panel, we have an extra heat exchanger layer at the bottom, and that is our patented design. So this is designed to efficiently take whatever the waste heat is generated on the top layer, it efficiently captures that waste heat and uses that waste heat to generate hot water. So this is how we are able to use more of sun's energy to generate both electricity and hot water from a single compact module and a single compact system. And because it's a single compact system, it's actually cheaper than installing 2 separate systems as well. And it develops more than 2 times overall energy than any of these standalone systems would. And that ensures that we can give a much quicker break-even to customers. So for example, PV systems have a break-even period of about 4 to 5 years for residences, maybe around 4 years for commercial. Our systems have break-even of about 3 years or 2 years for commercial clients. And also we've beefed up every specification so that our panels last 25 years, not just the PV part, but also the hot water part. So which is actually 3 times the lifetime of an ordinary hot water technology that is in the market today. And it's also designed to be a much lower maintenance product as well. So that is how we were able to combine both the technologies into a single product, and at the same time address all of the pain points that were holding back the customers and were holding back the customer acceptance for solar rooftop in India. So that's about our product. So we've launched this product just over a year ago, and so far we have more than 25 customers in different customer segments, including clients like Oyo, Novotel, Indian Railways, a lot of hostels as well. Also, we're working with premium builders in Hyderabad. We've been recognized as one of the best green energy companies last year. We've also been recognized and got a grant from United Nations to develop this innovative technology further. So that is about a company, about a product and how it works. When it comes to applications, so any customer who needs both electricity and hot water would benefit greatly from this product. So in commercial, we're looking at applications like hotels, hospitals, schools. In industries, it's textile, building materials, pharma, food processing, and of course, individual homeowners as well. And especially in reaction to COVID, where a lot of industries, C&I customers are struggling financially, we are rolling out a really attractive finance model. So we've teamed up with Tata Capital, and we are launching a RESCO model where we would invest in the system, and we would sell electricity and hot water to the customers at lower prices. I mean, the exact payment plan obviously depends on the customer usage and all that, but essentially the idea is that the customer should not have to invest in the solar system. And at the same time, because they get electricity and hot water for free, at a lower price, they are cash positive from day one. So there is no hassles of the finance guys trying to calculate IRRs and payback periods being too long and all of that. So we're trying to make it a lot easier, the decision to go solar, we're trying to make it a lot easier for our customers. So that's about our business model and about our company and product. So I'll be happy to answer any questions at the end. And thanks again for making this event happen. Yeah, thank you.
Thanks, Praneeth. This is definitely a very innovative technology, and with the business model that you just described, it will help in adoption like anything. Thank you so much. And I encourage all my participants to have any questions ready for him. Next, I have Mr. Venkat Kumar, who is Managing Director of Windstream Energy Technologies. Windstream has developed and tested the first of its kind integrated hybrid energy solution and is now marketing and selling solar mills to a worldwide consumer base in more than 35 countries. The solar mill is designed to generate power at lowest possible wind speeds and coupled with solar panels can provide energy generation 24 hours per day and 365 days a year. The technology is patented globally. Mr. Venkat is a graduate in Electronics and Communication Engineering from Vellore Institute of Technology, and he has more than 19 years of experience in renewable energy and IT sectors and has held management roles in various industries. Mr. Venkat, over to you. Sir, you are muted, I guess.
Is it okay now? You can hear me?
Yeah. Yes.
Yeah, good afternoon, everyone. And it's a privilege speaking to all of you in the expert quorum. And we at Windstream Technologies are into wind solar hybrid solutions. How do I control this thing? Okay. Let me quickly talk about why we need hybrid solutions. If you look at the wind and solar patterns throughout a year, both of them complement each other generally in any part of the world. If you look at the in a year, if you look at in summers, you have high solar radiations and the wind speeds are low, whereas in winters and rainy season, you will see a very high wind speeds while the radiation is less. So both of them complement each other, forming a perfect energy band. And what are the other advantages of hybrid? It's a more energy density, and if you're looking at the distributed solutions, which are more popular now, this gives you a more distributed energy possibilities, and we can custom design the solutions for the requirements, and we need not create it a place or generate it a place and transfer it long distances and where there are losses. And number three, where we are using the storages, it prolongs the storage capabilities. Okay, and what we are talking about is our solution, which is a vertical axis wind turbine. We have 3 turbine sets with generators below each of them, and three turbine sets make 0.5 kilowatt with a solar panel on top of it, which will make a 0.5 kilowatt. Totally a 0.75 kilowatt system at a 30 square feet footprint. Okay, which means the energy density for a kilowatt, which if a solar alone will be taking around 108 square feet, will be able to do that at 30 to 35 square feet place. Okay, and because of the design, it does not need heavy foundations and other things, which is one of the constraints of having small wind on the rooftops. If you look at the construction of this, it is a do-it-yourself kind of a system where we have steel, electronics, and plastic, where you can see a turbine is made of steel, a stamped steel of 2 parts combined together, and we have the top layer and the bottom layer. In bottom layer, you see 3 generators together, okay, which combine a 0.5 kilowatt system and which can be assembled easily. One of the biggest advantage of our system is being scalable and modular. It means that, hybrid system does not mean that you need to have 50% wind and 50% solar. It can be 10% wind, 90% solar, to 90% wind and 10% solar based on the resources available and the applications needed. And if you look at the applications, once you design a product like this, applications are innumerous. If you look at it, we have productized our projects into telecom towers where we have multiple systems, and then we have mobile mills where you can put it on a mobile platform and you can transport it anywhere. And this we use a lot for the defense purposes. And we have billboard applications, and I mean, these are banned in India, but we do it in desert areas in Middle East, where we provide the power for the billboard lightings. And these are the electrical charge stations that we have already deployed in defense for the Coast Guard. And we have done powering off for the fishing boats and the transportation boats in Lakshadweep, where we take abundantly available wind from the sea and the solar radiation, uninterrupted solar radiation, and we were able to save around 5 liters per each kilowatt installed. And we do use this in for the cage for fish farming, okay, for increasing the safety and also lighting up the cage fish farms. We have powered the resorts using the resort mills, where we have the wind walls developed for the resorts. And we also have mini grid solutions for island places. Okay, and coming back to for the farmers, we have built the coal chambers powered by renewable energy, where you can have an isolated storage this thing for in the farm itself, and a couple of farmers can own this so that they can use their farm in the best way. And the other thing is for the milk industry, we have built the chiller farms, the direct DC chiller farm, where they can store their milk without spoiling. And we have street light applications where we use solar as well as hybrid. And we have our factory in Hyderabad. We manufacture the entire product range in Hyderabad itself, and we export to 30 different countries. And to look at coming to the urban deployments, we have rooftop installations that we have done. And the best part of our installations is it does not only give the energy density that is required and within the less footprint, but also adds a lot of aesthetics to the building. If you are looking at it, the colors can be defined. It will add a lot of aesthetics to the building. And for the people in the urban area who want to show that they have gone green, that green tree hugger community, we form a big brand to them, So we can have various colors. It can go on any kind of rooftops. If you are looking at it, it has from the tilted roof, the flat roof, and it's scalable and modular system. It can go for, from 0.5 kilowatt to any megawatt or any kilowatt on the rooftop. And typically, if you look at these applications, we have done on the government buildings, on the school buildings, on the residential buildings, and the kind of power that we create, comes from the lowest wind speed. Generation from the lowest wind speeds. We generate power from 2 meters per second wind speed to 18.5 meters per second speed, after which the system itself it stops out because of the braking. And we have
Mr.
done.
Sorry to interrupt, but I would like you to wrap it up, please.
It's the last few slides. Okay, and we can go anywhere and everywhere. Okay, and we have these approvals from all the concerned agencies, and we have been awarded as the most innovative energy saving product award, the best electronics design award, and so on and so forth. And it has been displayed to who's who of the world and who's who of India, and liked and adopted many places. So I would love to work with the esteemed organization and would like to take it to the next level, adding value, energy, and aesthetics to the buildings. Thank you very much.
Thank you, sir. Thank you so much. Due to paucity of time, I would directly invite Mr. Siddharth Mayur, who is founder, president, and CEO of H2E Power. H2E Power is a clean tech company with a focus on developing cutting-edge technology solutions that helps to achieve energy independence and energy security. The product focus of H2E is solution based on solid oxide fuel cell technology for off-grid and grid-connected distributed power generation. Mr. Siddharth is a first generation social entrepreneur with a mission to bring about energy security and energy independence to the masses. A big believer in the power of hydrogen economy and fuel cell. Mr. Siddharth, over to you.
Thank you, Sonia, and thank you for organizing this seminar and inviting me to give a talk. I'm going to talk more about the technology and more about what fuel cells and technologies connected to fuel cells can do for the building industry. Sonia, how do I get access to? Yeah. Jonathan already mentioned about the amount of energy that buildings use and the amount of CO2 that buildings emit. And this forms a major part of the worldwide energy consumption and also energy emissions. And in the post-COVID era, where work from home is becoming more like a norm than a rule, the energy consumption from a home is expected to go up multifold as compared to what it was in the pre-COVID world. And more than the emissions, also the reliability of energy coming into a home is, I think, if you look at it from a customer perspective, we are all green ambassadors here. So for us, green technology is the big story. But for a consumer, it is reliability, it is 24/7, and it is affordability. So if you can give a solution which is equivalent or cheaper than the grid, if you can give the customer 24/7 good quality power, I think that is what is required at the end of the day. And with increasing in the demand, we need to innovate on technologies. We need to bring different technologies together to provide a sustainable solution to the customer. So we are in, again, like my other fellow panelists, we are a big believer in distributed power generation and distribution rather than having a large centralized plant and distributing it to different people. We believe that we should have one plant per building and one plant per apartment or one plant per house. So every house should be energy independent. Every house, every building should be energy independent. They should not bring anything from outside, and they should not send anything outside. So a big believer in the circular economy model, and working on that, we have devised solutions which are based on fuel cell technology, where we use gas which is coming out of waste plant in a building. So it can be syngas. We also produce hydrogen from that, or from co-electrolysis process. We produce the gas, we use it in the fuel cell and power the building. Fuel cell as a technology is one of the most efficient technologies for energy conversion. So we talk about 60% electrical efficiency and 92% combined heat power efficiency. So what we are innovating is, with the waste heat that comes out of a fuel cell, we are powering the heating needs and also the cooling needs. I call it CCHP, combined cold heat and power. And with that, we will be able to not only give power, but we'll be able to reduce the power consumption, because air conditioning and heating are the big energy guzzlers in the times that we live. So first you conserve energy, you replace it with a clean resource, and then make the whole story sustainable. And we've tried this in Europe. We have a very peculiar connection with Switzerland. Also, there is a connection today with the Swiss authorities. There is a Swiss company that we acquired earlier this year, and with them, we are looking at bringing the combined cold heat power systems to India. We already have about 200 to 250 installations all across Europe on the combined heat and power systems. And so this is the technology. When I talk about fuel cell, for people who do not know, it is an energy converter. We can take in hydrocarbon in any form. So it could be biogas, LPG, CNG, methanol, ethanol, even diesel for that matter. And we take that, we convert that into clean energy. In case of biogas, it is green. But in case of the other hydrocarbons, we cut down the SOx emission, NOx emission, CO, and cut down CO2 by almost 60 to 70%. So in the energy transition, this is the first step in decarbonization. And as we go forward, we're talking about defossilization of the world. On the reverse side, the same system can produce ammonia, it can produce hydrogen, it can produce syngas from renewables. So whenever there is inexpensive renewable power available, we do electrolysis of water, and we produce hydrogen or different gases, which can then be used. So it is a magic technology, as I call it, and it is 24/7. So we hybridize this with a solar, with a battery, so that we can get best of both the worlds and provide an inexpensive solution to the end customer. Hexis is our company in Switzerland, which we took over earlier this year. We have a full-fledged manufacturing facility there, employ about 30 people, and Very happy and proud. Also, what Jonathan said, that Switzerland is known to make cutting edge technology. So I talk on first-hand experience. We've got one of the best products in the market today, and we are looking at bringing this to United States, to India, and to different parts of the world. Fuel cell as a subject has been a subject of a lot of discussion worldwide. People in Japan, people in South Korea, in Europe, especially in Germany, are looking at hydrogen as a big story to power their energy matrix. It is said that by 2040, almost 50 to 60% of our energy matrix will be powered by hydrogen. So when I talk about fuel cells, we always talk about energy. We don't talk about electricity alone. So you're talking about bringing a solution for houses, for offices, for industry, but also for automotive, for airline industry, for the shipping industry. So you're looking at a whole gambit of industries that you serve. So therefore, energy and hydrogen, as they say, is the new oil. And we are very proud to say that we are the first Indian company to have a product on ground to produce clean and green hydrogen and use that for meaningful activities, either in the stationary segment or in the mobility segment. So this is the world that we envisage when we are talking about building as an industry, that every house should be a prosumer rather than become a consumer. So they need to produce their own power from their own waste using cutting edge technologies, and then be able to also make money out of that. So energy as a subject today, you pay money. Our vision is that a customer, especially a homeowner, should be able to make money. This investment should give him money. You should not look at a 3-year ROI or a 4-year ROI. You have to see how from day one it is going to make money for you. And using a combination of fuel cell, battery, solar, or wind and waste technologies, we have demonstrated this in more than one instance that we actually can make money. The place that I'm talking right now, my office where I'm sitting, is running on fuel cell, and for the last 1.5 years, my electricity bill has been negative. Of course, there is no net metering on smaller scale, but we are storing that in batteries, and those batteries we are using it in our auto rickshaw that we use for the company. So we are in a way carbon negative already, and we are making money out of the system that we've installed. So we're bringing this to Indian shores, and we're looking forward to decarbonizing, looking forward to saving places like Delhi, for an example. There was a big news today in the Economic Times that even the Green Ministry, along with Supreme Court, is looking at banning DG sets, but nobody says how are people going to live when you ban DG sets, because there are societies in Delhi who live only out of DG sets. So this is a solution for these people. We can install it within 1 hour, and it can be operational within 24 hours. And it has a long life, works for 10 years. Replacement cost is minimal. And I think this is one of the ways for us to actually have energy made in India. I call it Swadeshi Urja for Swavalambi Bharat, which is self-reliant India. Thank you very much.
Thank you, Mr. Siddharth. This is definitely very informative and innovative. Next, I would like to call upon Mr. Vivek Utpal, who is Senior Manager, EPSL Tri-Generations Private Limited. EPSL is a leading supplier and installer and maintenance provider for combined heat and power solutions that you just described, and is the official UK and Ireland distributor for MWM manufactured gas engine technology, the world renowned for achieving maximum efficiency, reliability, flexibility, and sustainability. Mr. Vivek.
Thank you, Sonia, and thank you, IIEC, for organizing such a wonderful webinar. Basically, EPSL Tri-Generation is a subsidiary of EESL, which is a public sector entity of Ministry of Power. So EESL has acquired a company in UK who is involved in this CHP solutions. So basically, we have a innovative business model in which there is zero investment from the consumers. ESL invest in the tri-generation projects, and the payout will be after the commissioning of project, and the payout will be a part of the savings. So right from the first day, you will have a part of savings, and a part of savings will be paid for the investment. So let us come on the energy challenges. So decarbonization, enable manage variability, uncertainty of renewable wind and solar. There is a there is a huge loss. There is a energy loss in transmission and distribution from the centralized power system. There is a chance of there is a frequent power failures. There are operational downtimes which lead to damage the equipment, loss of inventory, due to which loss of revenue, increased energy cost, drop in company value. So there are energy challenges in the existing scenario. So let us come on tri-generation. What is tri-generation? From a single fuel source, we have power, heating and chilling. That is tri-generation. So in our tri-generation model, we use natural gas as a single fuel source which generates power, and the waste heat will be recovered to provide hot water, steam, thermic fluid or the chilled water. So let us compare the tri-generation with the conventional system. So in case of tri-generation, a single fuel will produce 44% of electricity, means the electrical efficiency of the gas genset which we are using for this tri-generation is having 44% of efficiency. So 44% of the fuel is converted into electricity, and the losses will be recovered to provide heating and cooling. So efficiency of the heat will be 43%. So overall in this tri-generation, we are utilizing 80% of the fuel energy. Means the system efficiency is more than 80%. So in conventional case, the same 44% of electricity and 43% of heat, there are huge losses in grid as well as in boiler. So we have 158% of fuel consumption. So directly 58% of fuel can be saved in case of tri-generation. So in our tri-generation system, we use pipe natural gas to generate electricity, and there are two forms of heat. There are two forms of waste heat. There are two forms of waste heat. One is there are two forms of waste heat. One is exhaust heat, and another is cooling jacket water. So we use to provide steam from the exhaust heat, or we can convert the exhaust heat into chilled water by using a vapor absorption chiller. So 44% of fuel will converted into electricity. 18% of heat, exhaust heat, will provide you a steam from 8 to 12 bar at 8 to 12 bar pressure. We can provide thermic fluid for your process. We can use VAM. We are using VAM to produce chilled water from 1 degree to 10 degrees centigrade. We can provide hot water from the same system at 85 degrees centigrade. we can also provide chilled water for your process in minus temperature.
Mr. Vivek, may I request you to please wrap it up?
Yeah.
You have 1 more minute.
Yes. So, impact of business sustainability is lower environmental impact and enhance of overall system efficiency. Because in case of VAM, which we are using to generate chilled water, there is no refrigerant, means water is acting as a refrigerant. So, zero ozone depletion and zero global warming potential. So these are certain sectors where we can use hotel, hospital, airports, malls, district energy system, residential and commercial complexes. We can use this trigeneration technology. Advantages are cost saving, higher efficiency, reduced electricity consumption, buffer against increase in electricity cost. It is environment friendly. So these are the advantages of trigeneration system. Currently, we are having 2 projects ongoing in Mumbai. We have demonstrated several projects in UK. Thank you.
Thank you, sir. Thank you so much. Next, I have Mr. Samit. Samit Jain is Managing Director of Plus. Plus is a materials research and manufacturing company involved in the field of specialty polymeric additives for enhancing polymer properties and phase change materials for thermal energy storage. The company is developing technologies in-house with indigenous processes, enabling Plus to gain stronghold on the world's innovation map. Founded in 1994, the company has seen tremendous growth in recent past. Mr. Samit has been actively involved in various capacities and stages in all function at Plus since 2003. Currently, as managing director, he heads the overall strategy, marketing, and finance portfolio. He has led and conceptualization development of various new projects at Plus and has spearheaded the equity investment of Tata Capital Innovation Fund recently. Mr. Jain. Sir, you are on mute.
Thank you, Sonia, and thank you, IIEC and EDS for this opportunity to share what we are doing and how we can help integrate renewable energy. So, so far all the presenters have been talking about generating energy. So I'm going to move away a bit and talk about how we can store energy. And we store it as thermal energy, and this is stored in advanced materials, which we call as phase change materials, which can store the heat or cold. How can I control the yeah, so phase change materials. So what are these materials? These are essentially chemicals of different kinds which we manufacture, and they melt and freeze. And when they melt and freeze, they are in the process releasing heat or absorbing heat. Most common example that we know of is of ice and water. So when you freeze water, it becomes ice, and you're able to use that ice to cool your drinks, for example. Similarly, that happens at 0 degrees Celsius. So we work with materials which are from low temperatures as low as -30, -40 to as high as 100 degrees. So we have a whole range of 30, 40 different temperatures at which you can store energy. We know that renewable energy is not available at all times. If you look at solar, it's there for 6 to 8 hours a day. What do we do beyond that? So these are that's when these materials, for example, come into play. You can store that heat during the daytime and use the heat at night. Electrical storage is the most common thing that everyone talks about, storing energy in lead acid batteries, lithium ion batteries. That is well researched, it's expensive, and the efficiencies are low because you have multiple heat exchanges that happen. Thermal storage is a very old science, but is now being used for all the new applications that are being developed around it. It's very efficient in storage because you're storing heat as heat, or you're storing extra cold that you have at night as cold. In the next few slides, I'm going to talk about different applications with respect to building, how these materials have been used. This slide is a project that was done at IIT Mandi, and now we are trying to do it in cold areas like Ladakh. It's the extension of a solar water heater in a very simple way. So evacuated tube collectors that you can see in the image on the left is being used to heat the phase change material and not the water that is typically done. This phase change material is actually stored on the right when you see that picture of the gray colored thing. So that's the phase change material inside there. So the heat comes in through the ducts into this gray box that you're seeing and is stored there, and then this acts as a heater during night. So we are able to use the heat generated in the daytime and keep the room warm at night. The below graph is showing you, like, the outside temperatures have been varying from, let's say, the red orange color, -10 to plus 4 degrees, plus 5 degrees. But the inside room temperature has been constant between 15 to 25 degrees Celsius, simply by storing the heat. In the next slide, can we change this slide? Yeah. So the next slide here, this shows the chillers which are there in buildings. When you have large office complexes, for example, and they have huge chillers, these office complexes typically need energy from, let's say, 9 in the morning till 5, 6, 7 in the evening, and they are closed at night. With dual tariff coming into place, electricity being cheaper at night, for example, you can run your entire chillers at night. You will run the chillers more efficiently and would be able to then store the energy at night and then draw it in the day. So there you save money, but you also have efficiency because the chiller is working at a lower ambient temperature at night and can therefore work more efficiently. The other application that is used is that sometimes when you look at a country like, let's say, in Europe, if you look at countries like Netherlands, Ireland, Switzerland, etc., the nighttime temperatures are low. They're below 18 degrees Celsius. The daytime temperatures are 25, 26 degrees Celsius and beyond, like 30, 35 also at times, for example, these recent summers. So I can store the 18-degree cold at night also in a system like this. So I can have a system where I circulate cool air which is at 18 degrees, freeze the material that I have and use it to absorb the heat. In the next slide, I think there is some problem in the presentation, Sonia. Can you go to the...
Can we go to the next slide?
I seem to have lost the... If you can go to slide number 6. Yeah, so this is a building in Ireland where the chillers that you saw in the previous slide have been integrated. You have more than 18,000, 20,000 square feet of area, which is cooled simply by storing the nighttime cold energy. In the next slide, there is another passive system. Yeah, so this is another building that has been done in Netherlands. Here we are using just the cold air at night. The phase change material that you see in the center, these black pouches, these are in the left picture, they are actually in the whole duct line in that thing in the ceiling. And the cold air comes in at night, freezes this material, and during the daytime when the temperature in the room gets to beyond 23-24 degrees Celsius, the heat which rises up is absorbed by these materials, thereby reducing your air conditioning costs drastically, because a lot of your heat has been absorbed in these materials and stored there. And this maintains the room temperature very comfortably around 25 with much reduced active chilling. If you go to the next slide, please. So this is another way of integrating it. These are integrated in panels, and these panels are lined on the wall. Again, at night, you throw in the cold air, and during the daytime, you are able to absorb the heat and maintain the temperature. Next slide. This is a trial that was done in India. So most of these have been done outside India so far. In India, we have started experimenting. The first slide that I showed you for IIT Mandi, for example, this was done at CEPT in Ahmedabad. The PCM was installed inside the room, and the temperature that you see, the interior temperature is the dark blue color when you have phase change material, and outside temperature is the light blue color. So while you have variations which are drastic, the temperature inside the room is maintained in a ambient temperature of approximately as 32 degrees Celsius or so, with just free cooling that you get because of the diurnal temperature difference in a city like Ahmedabad. Next one.
Sir, can I please ask you to finish this up?
Yeah, so this is another application. This is under the floor. So when you have radiant cooling or radiant heating, for example, you're circulating cold water or cold or hot water, you can again line it with the phase change material, and the extra heat gets captured. So it increases the efficiency of your radiant system. So these are the kind of applications that can be done using such materials to be able to work in a more effective way. The next two slides give you an example of, can someone change the slide, please?
Yeah, it's visible.
Look, if you can go to the next slide. Yeah, so this is a list of projects that have been done, which vary from as low as 50, 60 TRH to as high as a few hundreds of TRH to be able to increase the efficiency by capturing cold energy or hot energy. So essentially, these will play a big role in India, in cold places, particularly for heating, and in other places, it will be reducing energy consumption by storing the cold available at night. Thank you.
Thank you, Mr. Samit. I would now invite Mr. Gagan. Gagan is an engineer with Masters in Electrical Engineering and Renewable Energy, and he has over 8 years of experience in the field of renewable energy. He has been working at Griha Council for 3 years, and he is currently looking at business development trainings and rating reviews for the Southern Zone. Prior to joining Griha, he has worked as expert consultant and at the Ministry of New and Renewable Energy, and he has represented ministry at various state level workshops. So let's hear from him the building sides of it. So we've looked at the technologies. Now let's hear from him.
Hi everyone, I hope I'm audible. I think at the outset I would like to thank IIEC for giving Griha this opportunity to sort of present during this this webinar of yours. It's really heartening to know and understand the different technologies that the various panelists presented during their short presentation. So without wasting any more time, let me just go into my presentation. So Griha basically stands for Green Rating for Integrated Habitat Assessment. It is nothing but a tool. It's essentially a rating system, so it's nothing but a tool which facilitates the design, the construction, and operation of a green building, and in turn measures how sustainable or green your building is. So this rating body is one which was adopted by the Ministry of New and Renewable Energy back in the year 2007, and it was developed and by the Energy and Resources Institute, that is TERI. Now, the concept by which Griha works is what gets measured, gets managed. As we all know, even with respect to your energy generation or energy consumption, only if you know how much you generate or how much you're going to consume, only then will you be able to manage it. And the same works with respect to every other sort of, let's say, resource, whether it's water, whether it is the amount of waste generated, etc. Now, over the last few years, Griha has got a lot of endorsements, both national and international. As I said, back in the year 2007, Griha was adopted as a national rating system by the Ministry of New and Renewable Energy. It has also been recognized as a tool for implementing renewable energy in the building sector by the Climate Realty Project founded by Mr. Al Gore, the former Vice President of the United States, back in 2008. It's also been recognized as an innovative tool for sustainable development by the United Nations in 2009. And also the UNEP Sustainable Building and Construction Initiative has developed the common carbon metric for international building energy data collection based on the inputs of Griha Council. But what I would want to talk about a little more is what happened back in 2015 during the COP21, where there was a significant agreement signed in order to mitigate the negative effects of climate change. Now, before the actual conference, everyone is aware that there was something called the INDC, the Intended Nationally Determined Contribution, which is a document of over 38 pages, which India basically submitted to UNFCCC. It is nothing but a pledge that India said that we are going to do these things in order to mitigate the negative effects of climate change. There are 8 significant steps or pledges which India took, but 2 of them are very, very significant. One of which spoke about reducing the emission intensity of India's GDP by 33 to 35% by 2030 compared to its 2005 levels. And another very significant thing that India committed was about 40% of the cumulative electricity power installed capacity will be through non-fossil based fuels by 2030. That's where you come into picture. I mean, all the panelists come into the picture, because here we're talking about non-fossil based fuels, we're talking about renewable energy technologies, etc. Now, in that particular document, Griha has been recognized as India's own rating system, and it has also been mentioned that it is going to be a part of the mitigation strategy for combating climate change in the India's INDC. With that, how is Griha working with respect to renewable? I mean, considering that it's a national rating system, Griha has different variants. Now, of course, in Griha, we don't look at a variant. I mean, we don't look at buildings or projects from the typology perspective. Rather, we look at it from the quantum or the size perspective. So we have the new building rating systems, which is Swagriha, Griha LD, and Griha for affordable housing. Then we have something for existing buildings, and also we have a rating which has been developed keeping the cities in mind, considering the 100 new smart cities and also the new cities that are getting developed, etc. Now, I will not want to spend a lot of time into what are the different variants that we have, but let me say how Griha has been able to integrate renewable energy systems into its rating. In Swagriha, which is the smallest rating variant that we have ensured so renewable energy constitutes 4 points out of the total 50 points in that particular rating variant. And here we're talking about both energy generation as well as solar water, hot water requirements. So with respect to energy generation, we say that at least 1 kilowatt of renewable energy system should be installed for a project which has a built up area of about 500 square meters, and up to a maximum of 3.5 kilowatt. With respect to water as well, points are awarded to the project in case they're able to install solar hot water systems, which is able to cater to at least 50 to 70%, 75% or more of the daily hot water requirement. Coming to a most prominent rating, Griha version 2015, it's a mandatory requirement for a project to have renewable energy integrated in that particular project or that particular building, along with 7 other points. So we look at it from an on-site, off-site perspective. So for a daytime commercial, it's mandatory for them to offset about 2.5% of their annual energy consumption with respect to heating, ventilation, and AC and interior lighting consumption. And they get about 7 points in case they're able to offset 25% of that. With residential, it's not mandatory. However, they get points from 5 to 25%. And with 24/7 operational building, it's about 0.5% has to be offset through an on-site system, and they get points in case they're able to increase it up to 10%. With respect to off-site, 100% of the building's annual energy demand should be met because that's a mandatory requirement as per GRIHA version 2015. In 2019, which is our latest version, which we launched back in December 2019, here it's again a mandatory requirement, and 5 points have been attributed to the renewable energy system. And we've increased the percentage with respect to mandating it. So we've gone ahead with 5% for daytime commercial and 1% for 24/7 operational building. We have another rating called GRIHA for affordable housing, keeping in
Gagan,
mind
you
the
have,
Pradhan was.
sorry, Gagan,
Yeah,
you have 1 more minute, please. Yeah.
Yeah. I'll just finish it. I'll wrap it up really quickly. So GRIHA for affordable housing has, where we have attributed 6 points out of the 100 points. And then we have GRIHA for large development, where about 18% of the total weightage has been attributed to renewable energy. Moving on with respect to existing buildings too, we've ensured that this particular renewable energy concept has been integrated to the system, the rating system rather. So here it's mandatory, and you get 15 points out of the 100 points in case you're going with a renewable energy. So these are the various ways in which GRIHA is ensuring that whatever policies of the government is, whether it's the National Solar Mission or whether it is something to do with wind, with biomass, etc., is getting implemented all across the country with any project that GRIHA has. Now, GRIHA has over 1,700 or 2,000 odd projects with about 5 crore 25 lakh built up square meters of built up area. Now, we also have something called the GRIHA product catalog. It's an online catalog which has been developed to promote green building designers, architects, consultants, technologies, etc., with all necessary information on green building products. So any new technology can basically go ahead and register themselves under the GRIHA product catalog, because that would help the project to choose the right technology based on their requirements and needs. So with that, I would like to thank you. And again, I would like to congratulate the IIEC for conducting this, and also for the project of integration of renewable energy in the buildings in India. Thank you.
Thank you, Gagan. That was very informative. I would also like to announce that the BEEP RE project that IIC is currently doing has entered into an MOU with GRIHA, and we will work on expanding this RE technologies part for them. And we will also look forward to supporting some of their own projects for integration of RE technologies further. So with that, my technical session ends, and I would like to take up a few questions. I have received a lot of questions, but due to paucity of time, I will take only a few questions here. We will answer rest of the questions through email or directly put you in touch with the panelist so that you can take this up with them. So first question is for Mr. Hari Narayan. Sir, what is the cost of BIPV installation for facade, and what is the reduction in energy when compared to rooftop if we talk about BIPV solar?
With respect to the costing, it actually varies a lot, and it's not something we can just sort of throw up in the air, simply because we have to decide what kind of lighting you want, whether you want the light to be admitted, not admitted, whether you're replacing glass, existing glass with BIPV. I don't want to throw numbers at this stage for BIPV just like that. Having said that, in the specific building which we worked, the increase in cost vis-a-vis what they were planning to do was about 20%, and the payback for that increased investment was about 4.5 years. Is what we have calculated. The generation varies depending on which side of the building is facing. If it is south side, it's actually quite good. It's still about only about 60% of the generation that you can expect from a normal rooftop. If it is sort of north or east-west, then the generation falls down. It's probably not advisable to do it on the north-facing roof. North-facing facade, sorry.
Okay, thank you, sir. Next question is for Mr. Rajesh. Sir, is the 10% lower water requirement and full remote monitoring capabilities a patented difference?
So it's not 10% reduction, it's actually 10% of usage of water. compared to 100 to 200% that normal system uses. So that particular part isn't it's not a patent, but we have developed the system to take that quantum for a couple of reasons, that we are able to manage the biological health at that heavy a load with so little water, and it also ensures that the size of the plant. When we talk about the footprint, one of the reasons why the footprint is small is because we use less water, because even if you add more water, the number of days it has to hold the same. So the lesser the water, the lesser the volume it holds, the lesser the footprint. There is no specific patent related to that. We have 3 other patents which are related to the heating side, the gas management side, and the health monitoring side.
Right. Thank you so much. I have another question for Mr. Samit Jain. PCMs are not widely used, though they are very effective. What is the reason, and how can they be promoted?
So we've been trying to promote PCMs for almost a decade now. I think the reason for PCMs not being widely used outside India in particular was because electricity and fuel was always very cheap. And the first large usage of PCMs for such applications happened, in the 1970s when there was an oil crisis. A lot of large companies got into it, but then subsequently prices dropped once again, and people resorted to going back to the old ways of using fuel. In the last few years, one has seen a great move towards sustainability, and once again, Europe, that's why most of our projects have been there, has been leading the way in trying to adopt newer applications where PCMs can be used. And we also now see that happening in India. So I think it's only a matter of time that as sustainability has become a focus, and you see the same thing with solar, right, that over the last 10, 15, 20 years, the prices have dropped drastically. So so it just takes a while for any technology to get adopted, I suppose, and the time for such technologies are now. The adoption, I think, in the next 5 years is going to be much faster.
Thank you, sir. I have one question for Mr. Venkat. So what are the noise levels in your hybrid systems, specifically in the systems that have been installed in resorts?
See, we have zero noise because we don't work on the principle of barring the wind. We go along with the wind, and so the noise levels are zero.
Perfect. Thank you so much, sir. I would not, I'm so sorry, but I can't take any more questions now. I will separately email these to the panelists, and you will get the answers back. With that, I would just like to close our session, and would like to invite Dr. Bibek Bandyopadhyay for delivering the vote of thanks. Dr. Bibek is the former director of Solar Energy Center, the Solar Institute of the Ministry of Renewable Energy, New and Renewable Energy. He started his career in solar energy at the Indian Institute of Technology, Delhi. He served at the Department of Science and Technology and in various capacities for more than 31 years. As one of the senior most advisors of the ministry, Dr. Bandyopadhyay was associated in the formulation and implementation of Jawaharlal Nehru National Solar Mission. He is instrumental in promoting hydrogen and fuel cells as an emerging technology in the country. He is associated with a number of national and international committees relating to emerging energy technologies. So, sir, you are mute.
Is it okay?
Yes.
Okay, thank you, Sonia, and good afternoon to everyone. I'm very happy to be associated with this project because I started my career with such an intention of making buildings solar efficient. Now, with the advent of renewable energy and its rapid growth, we had the hopes that will be able to make buildings, as Dr. Janathan has rightly pointed out, from consumers to prosumers. But then, as we have seen, you need appropriate technology that can effectively be integrated in a reliable manner and certainly in an acceptable economic terms and conditions to give the ultimate energy and environment benefits. I'm very happy today that we have got presentations from a very well-established technologies. They have brought these appropriate technologies. And let me say, you know, the BIPV system which Harinarayan has presented, it is certainly a required thing because it can be the architectural element in the buildings. Though rooftop solar has been going on very rapidly, and the necessary regulatory and policy environment has been established in the country, but in order to make it more widespread, it is necessary to integrate the technology directly with the building, with the architecture of the building. And nowadays, as the cost of solar photovoltaic has come down, so it is possible to do it because we are not very much bothered about the orientation or few degrees of inclination of the solar photovoltaic panels to get the maximum benefit of the sun. So BIPV is certainly a very appropriate technology which we would be able to introduce. And then we have seen the presentation of Mr. Praneeth, Mr. Rajesh. You know, waste, one of the daunting problems for managing a building is managing its waste that we generate. So he has given a technology which is essentially the reincarnation of our old biogas technologies in the urban environment to manage waste efficiently and also to produce energy out of that. And then that energy can very appropriately be used in many places. And we have seen presentation of fuel cells, which can use that energy to provide electricity and also heat. The wind and solar, these are complementary energy sources and very appropriate technology I have found presented by Venkat. Yes, it's a very good technology. You know, I have been working for, as Sonia has pointed out, more than 30 years in this field. But the technology which I found, that solar wind hybrid technology, which is not very difficult to put on the rooftop or integrated to the building to produce the energy which is supplementary to each other. And I have left one, that is the PVT module. Obviously, that is to squeeze the maximum out of the photons of the sun. You take the electricity and also the wasted heat that can be used for heating water and space heating. Then we have the EPCL company, which has not only come out with the tri-generation technology, but has also given a unique business model that people can use those technologies without investing directly. I think EESL will devise models to integrate these systems in the buildings, take the burden of the investment and recoup it, because we have seen economically these systems are going to be rewarding, because the other cost of energy and electricity is going up, whereas the renewable energy electricity is going down. And Gagan has presented the regulatory aspect and the rating aspect of these buildings. This was one of my very pet projects which I did in the ministry. And it's good that we have already signed an MOU with Griha to implement this project. Excellent presentations, and not only that, what I found that most of these technologies are now available in the country. They have some collaboration with Switzerland, certainly a country that has been pioneering these technologies for building integration. So when these technologies are available in the country, we will be able to give a building integrated designs in a
I think, Sonia, there is some problem. You can wrap it up now, I guess.
I think, yeah, we've lost Dr. Vivek. As Dr. Vivek was mentioning, this was an excellent cohort of presentation. All these technologies are very useful and would definitely pave a pathway for Indian building landscape to move forward towards zero carbon or net zero energy buildings. And we are very happy to be associated with this project at the moment so that we can step the right stones for the future. With this, I would like to end this session today, and thank you very much for all the participants, speakers, and panelists, and especially Dr. Jonathan for joining us today. Thank you so much.
Thank you.
Thank you all.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you very
Thanks,
much.
everyone. Thank you.
Thank you. Take care.
Thank you.